Good morning. I am Ananthi, Assistant Professor Biomedical Engineering in Emmanuel JJ College of Engineering. Now I am going to present a PPT on wide area monitoring system. What is wide area monitoring system? That is, in smart grids, the increasing technical complexity in interconnecting multiple grids together across the need for wide area monitoring system. It is employed for the following reasons, that is, it is fast and efficient in detecting and responding to faults and disturbances. Thus, it results in improved reliability. It also provides real-time data about grid operations and helps in better management of the grid. It also reduces the impact of faults and disturbances on the system by rapidly detecting and isolating them. It improves the sustainability of the grid through the integration of the renewable energy sources. The main components are PMU, phasor data concentrator, monitoring and visualization applications, and control and remedial actions. Thus, first PMU. The PMU means phasor measurement unit. It is a device used in wide area monitoring system to measure the electrical waves flowing in the grid and to provide their data like voltage, current, and frequency in real time. It consists of GPS receivers and microprocessor based devices like relays, fault recorders, etc. and communication system for transferring the PMU data to phasor data concentrator. PDC. PDC is the phasor data concentrator. These are the systems that used to collect the electrical parameters measured by the number of PMUs. It is responsible for collecting vast amount of phasor data captured by PMUs, correlate them and feed as a single stream to other applications. How does VAM system work? First, PMUs installed across the entire grid measure the electrical data and time synchronize this data using the GPS satellite signal. The data collected is then transmitted to phasor data concentrator through a secure communication network where correlation of the data takes place here. The correlated data is next it is fed to VAM application to process and analyze and also to validate the real-time condition of the grid. And the next step, the visualization application show the grid conditions and potential issues in the grid based on which the control room operators make the decision and take remedial actions. We have some advantages. First is in real-time monitoring. The wide area monitoring system provides the up-to-date information about the grid operations and conditions. And wide area monitoring system provides the stability of the electrical grid by rapidly detecting and isolating the faults and disturbances. VAM system helps in the faster and accurate fault detection through high-speed communication. Wide area monitoring system enables grid operators to better manage the resources and improve the overall efficiency of the system. We have some challenges in this VAM system. The implementation and the deployment of wide area monitoring system is cost intensive task and also it requires a high investment. There are also issues in availability and setting up of high speed communication and infrastructure for WAM system. The implementation of WAM system in smart grid needs setting up of standards and compliances. Setting most appropriate locations for installing PMUs is also a big challenge in WAM system. It also vulnerable to cyber security issues. It requires advanced tools for in-depth analysis of grid data, which is complex technology intensive task. It is also needed to develop better visualization applications for system operators. And some of the applications of VAM system is it monitor the grid condition and stabilize the operations, and it detect and inform the grid operators about potential issues, rapid detection and isolation of faults, load balancing to distribute the load evenly across the grid. It managing the renewable energy resources integrated to the grid. These are some applications of WAM system. So now we have get an idea about VAM. So let us conclude my topic. Thank you.